In this lecture I am going to solve 5 problems on the transient concepts in previous gate questions only. This question came in 2015 for 2 marks. In the circuit shown, switch SW is closed at t equal to 0 and assuming initial conditions, 0 initial conditions, the value of Vc of t in volts at t equal to 1 second. This type of questions are very important. Now he said whenever the switch is closed at t equal to 0, that means it is opened at t equal to 0 minus, and he said initial conditions are 0. That means whenever switch is open, the source is not connected to this RC network. That means I can directly take Vc of 0 minus is equal to 0. Now when t equal to greater than 0, so we have to write down the circuit for t greater than 0, which is plus minus 10 volt, switch is closed, 3 ohms, this is 2 ohms, and this capacitor is present will be here, that is 5/6 farad. That means for t greater than 0, the source is connected to RC network. Then we have to come, in your mind, we have to use this formula. Vc of infinity plus Vc of 0 minus Vc of infinity into e power minus t by tau, and tau equal to RC. Now in the question itself is given 0 initial condition, so Vc of 0 minus is nothing but 0, but we have to find Vc of infinity. For t greater than 0, that means t greater than 0 means it up to infinity. So what happens to capacitor? It's simply open circuit. So what is the Vc of infinity? If this is open circuit, simply apply voltage division rule. So Vc of infinity is nothing but 2 into 10 by 3 plus 2, 5. So it is a 4 volt, right? Now once we know this value and I need tau, so where we are finding the equation for Vc of t across 5/6. So capacitor we know 5/6 farad. Now I need R equivalent. When I am finding R equivalent, we have to open the capacitor. When I am looking into the capacitor, what is the equivalent resistance? Whenever there is independent sources, make them short. Now what is this equivalent resistance? 3 parallel 2. So R equivalent is equal to 3 into 2 by 5. So 6/5 ohms. Now what is the tau now? 5/6 into 6/5 is nothing but 1 second. Now according to this formula, Vc of infinity is given 4 plus, we found already this one, Vc of 0 is given, so 0 minus 4 into e power minus t by tau. Tau is equal to 1. Now what is this value? If we take 4 common, 1 minus e power minus t. But he mentioned at t equal to 1 second. So what is the t equal to 1? 4 into 1 minus e power minus 1 is a volt. So you can use calci finding this one. So I can go for 4 into 1 minus 1 by e. What is e? 2.178. So 1 minus 1 by 2.718. Then you can solve, we will get the value. So this is how to do this type of problem. Second question, it is gate 2014 again for 2 marks. He mentioned, he didn't mention anything about these switches, but we can easily get. But we need to find V naught of t at t tends to infinity, or V naught of infinity. Where is V naught? Here. Now when you see this is a current source and 10 into u of t. We know that 10 into u of t is nothing but 0, and t greater than 0 the value is 10. That means up to t equal to minus infinity to 0, the switch will be open, then source free. The moment t equal to 0, we apply this current. That is the meaning. But we don't require all this concept. We require only at t equal to infinity. At a t equal to infinity, what is the circuit will behave, right? So t equal to infinity, this current source is nothing but 10 ampere, and this is the dependent current source plus minus 2 into ix, and here given 5 ohms, and here inductor. So whenever inductor is there at t equal to infinity, that is steady state reached, it will become open, short circuit. So short circuit means this is ix, and here 5 ohm. So this is not V naught of infinity. So single equation we get the answer. See, V naught of infinity is nothing but this voltage. So this is a parallel. So what is this node voltage? Simply V naught of infinity. If we apply nodal equation, we will get one equation, that is, see at this node what is the incoming current? 10 ampere. So if I assume this is leaving minus 10 plus V naught of infinity minus this voltage source minus 2 times of Ix by 5 plus this is Ix but don't require Ix, so V naught by 5 ohm, so directly V naught of infinity by 5 ohm, right? But Ix is there. What is Ix? Ix is nothing but V naught by 5 only, because this is the current. If you substitute here, if you take V naught of infinity common, this is 1 by 5 minus 2 by 5 into Ix. Ix is again V naught by 5. Again I have taken V naught common, so 1 by 5 plus 1 by 5 is equal to 10. So what is V naught of infinity? So it is 25. So 1 by 5, 1 by 5, 2 by 5. So 10 minus 2 is equal to 10. So what is the V naught of infinity? It's nothing but 250 by 8. So if you solve, we will get 13.25 volts. Simple nodal analysis if you use, and at t equal to infinity how the inductor behaves, then we can solve easily. Next one is GATE 2004, again 2 marks. He mentioned the capacitor initially uncharged, that means Vc of 0 minus equal to 0. Find I of t in milliampere for t greater than 0. Actually they should ask what is Vc of t for t greater than 0. Now they are asking. Now we know once we find this voltage, suppose this is the parallelly showing voltages Vc of t. So what is I? Vc of t by 2 kilo ohm is I. So we will find Vc of t. Now initially uncharged and this 5 volt is now connecting. So again we have to get this expression Vc of infinity plus Vc of 0 minus Vc of infinity into e power minus t by tau. Now Vc of 0 is given 0, but we have to find Vc of infinity. I am going very straight. So at infinity the capacitor will become like a open circuit. So what is Vc of infinity? Again voltage division rule. So Vc of infinity is equal to main voltage 5 into this resistance 2 kilo by total resistance 3 kilo. So we will get 10 by 3 volts or 3.3. Now Vc of 0 we know, Vc of infinity we know, we need to find only tau. Now where we need to find the tau? Open the capacitor, then looking into the inside the circuit, make independent sources 0, so it is nothing but 2k parallel with 1k. So R equivalent is nothing but 2k parallel 1 kilo. So it is nothing but 2 by 3 kilo ohms. That's it. So what is Vc of t? Vc of infinity 10 by 3 plus 0 minus 10 by 3 e power minus t by tau. Tau is equal to 2 by 3. Tau is equal to R into C. So tau is equal to, what is R? 2 by 3 kilo ohm into C. C is given as 1 microfarad. 1 micro means 1 into 10 to the power minus 6. Kilo means 10 cube. It's gone minus 3. It's nothing but 2 by 3 millisecond. So it is 2 by 3 into milli. Now if we take 10 by 3 common, so it will become 1 minus e power minus t by tau, and tau is equal to 2 by 3 millisecond. This is Vc of t, but we don't require Vc of t, we require I. I of is equal to Vc of t by how much? 2 kilo ohm. So 1 by 2, so 10 by 3 into 2 kilo. So 2 kilo means we will get in milliamperes. So t by tau in milliamperes. So 2 5. So final answer is 5 by 3 into 1 power e power minus t by tau milliamperes, and tau is here 2 by 3 millisecond. So I am going very fast because already we know this concept, that's why. So it's only required only 30 seconds, maybe 50 seconds to solve this type of problems. And the next one is GATE 2014, again for 1 mark. He mentioned the switch is open for a long time, that means this is open. At t equal to 0 plus, the magnitude of current in milliamperes through the 4 kilo ohm resistor. We have to find a current across this at 0 plus. Now we know first we have to find at t equal to 0 minus what is the circuit condition. So plus minus 10 volt, 5 kilo ohm, and whenever there is a capacitor T equal to 0 minus means it is reached a steady state, so Vc of 0 minus, and the switch is open, so it will have 4 kilo ohm. Switch is open, so no problem. This is 1 kilo ohm. Whenever there is an inductor, it becomes short circuit. Now see, it's very simple. What is this current? I of 0 minus. So only one source and 3 resistances. So 10 is equal to I into 5 kilo plus 4 kilo plus 1 kilo. 5 kilo. So sorry, 10 kilo. So what is I? We will get 1 milliampere. Now IL of 0 minus, we got 1 milliampere, which is nothing but IL of 0 minus. Again I am telling, this is open circuit, no current flows, only the current is flowing through this path. So that is equal to I of 0 minus. Then by KVL we can get like this. Then we can get IL of 0 minus 1. But we need Vc of 0 minus also. So Vc of 0 minus, how to find? Apply KVL here. So minus 10 plus 5 kilo into 1 milliampere plus Vc of 0 minus equal to 0. Now what is Vc of 0 minus? 10 minus 5. Milli into kilo, cancel 5. So 5 volt. But he asked at T equal to 0 plus. So we need to draw T equal to 0 plus. What is the circuit? Plus minus 10 volt, 5 kilo ohm. Now at T equal to 0 plus, the capacitor will become short circuit with initial voltage, that is 5 volt, and this will become a short circuit. Again I am not telling, going again analysis. C is at T equal to 0 minus, it will become open circuit. T equal to 0 plus, it will become short circuit with the initial voltage. Now there is again 4 kilo ohm resistance. Then now if you observe, the switch is now closed. Now it is closing, so this is the short circuit. Next, this is 1 kilo ohm, and the inductor is now open circuit at T equal to 0 plus, but with initial current, as we already found, it is 1 milliampere. So 1 milliampere is IL of 0 minus. We need to find I of 0 plus here. Now how to find this one? It's very simple. Whenever there is a short circuit, this is connected to ground, so this voltage is nothing but 0 volt, and this voltage is nothing but 5. That's it. I know the difference voltage, so I of 0 plus is nothing but difference 5 minus 0 by the resistance 4 kilo ohm, which is nothing but 1.25 milliampere. Now how to prove? We know this 1 milliampere is coming here, so this is 1 milli and this is 1.25 we got. So what is the remaining current? 0.25. Again this is coming back here, which is 1 milli. What is again? 1.25 milli, right? Now if you see here, this is 10 volt, this is 5 volt. So 10 minus 5, 5. 5 by 5 kilo, 1 milliampere. That means it should enter 1 milliampere. So what is the remaining current? We will get 0.25 milliampere. So at each and every node the KCL is verified. That means what we got is the right answer. And the last final question. This type of questions is not came in previous, but we can expect this time. The switch is opened for a long time and it is closed at T equal to 0. Find the value of DIL by dt at T equal to 0 plus ampere per second. Sometimes they will ask d square IL by dt square and so on. So if you solve this, then it will be very easy. Now at T equal to 0 it is. So first we need to find the previous condition. At T equal to 0 minus, what is the circuit? So this switch is now open, now it is closing. Previously that means it is open, so this source is not connected. This is 1 ohms and switch is open. 2 ohms. Whenever there is a capacitor, it will become open circuit, so Vc of 0 minus. Whenever there is an inductor, it will become short circuit, IL of 0 minus. Next one, this is a plus minus 10 volts. If you observe, there is no closed path at all. That means what is the Vc of 0 minus is nothing but 10 volt. What is IL of 0 minus is nothing but 0 ampere. Right? Again I am telling, there is no closed path at all. Right? So whenever there is no closed path, current all branches current is equal to 0. That means when you apply KVL, this voltage is nothing but, see, minus Vc of 0 minus plus 0 plus 10 equal to 0. So Vc of 0 is equal to 10 volt. And IL of 0 minus is 0. But he asked at t equal to 0 plus. So now draw the circuit at t equal to 0 plus. At t equal to 0 plus, the switch is now becoming closed. So now 5 volt source will exist now. 5 volt, 1 ohm, 2 ohm, and the capacitor will become short circuit but initial voltage. So initial voltage is 10 volt, then it will become a short circuit. And what happens to inductor? Inductor will become open, and there should be some initial current, but that initial current is also 0, so it will simply open, and it will have VL of 0 plus. Remember, even if it is open, the voltage will exist, and here there is a plus minus 10 volt, right? Now how to solve this problem? Whenever there is a dIL by dt, so we know the concept of like this. What is VL across the inductor? L into dIL by dt. If I know this VL at t equal to 0 plus, then I can find easily dIL by dt. Now what is that VIL? So if I know, suppose at this node, if I find this voltage, then we can find easily. Again, one nodal equation. See, this is open circuit, no current flows, so simply 1 KVL you can get. So whatever the current flows here, I, that is only flowing here. So if we write a KVL, minus 5 plus I into 1 plus I into 2 plus 10 equal to 0. So what is I now? So 3I is equal to minus 5 plus 10, so 5, it is minus 5. What is I? Minus 5 by 3 ampere. So that means the current is flowing opposite direction, right? That is like this. So this is 5 by 3 ampere is going. That means it should enter 5 by 3. This is plus minus, so 5 by 3. So what is the voltage if you apply KVL? Or see, I know this current 5 by 3. 5 by 3 into 2, 10 by 3 volts. Now minus 10 plus 10 by 3 plus V equal to 0. That is a KVL. So minus 10 plus 10 by 3 into 10 volts plus V equal to 0. What is V? 10 minus 10 by 3. So what is V? 30 minus 10. So 20 by 3 volts. That is V. Or V1. We will assume as V1 because both are same. This is V1. Now it's very simple now. I need VL of 0 minus, right? Now I know this branch voltage as V1. So what is the, I can again write V1 is equal to VL of 0 plus the 10 volts. The given as 20 by 3. So 20 by 3 is equal to VL of 0 plus 10. What is VL of 0 plus? 20 by 3 minus 10. So minus 30. So plus 20. So minus 10 by 3 volts is VL of 0 plus. But I told you what is VL of 0 plus? L into dIL of 0 plus by dt, which is minus 10 by 3. But I need this one. But what is L given? L is given simply 1 Henry. So 1 into this. So this only. So dIL by dt at t equal to 0 plus is equal to minus 10 by 3 amps per second. This is how to find this one. If they ask what is a dVc by dt at t equal to 0 plus, find first IC, then IC is equal to C into dVc by dt, then we can find dVc by dt as IC by C. So we can solve so many problems like this. So this is some problems I did. You have to solve at least from each concept 4 to 5 problems on transients, right? RL, source free and with source. Similarly RC, source free, next one is and with source. Some questions on this, how to find dIL by dt, dVc by dt and so on, right? So this is the 1 week. So you have to solve at least 4 to 5 problems on each concept. You may get 1 question or may get 2 marks question or may get 1 marks question in GATE exam, right? So don't neglect, we will get pakka question on this transient. But this is the, I can say 80% only. So the remaining 20% like RLC network, RLC network, that is also simple, but not now, because we cannot solve or we cannot go for a new topics. I should not start the new topic, but this is a very simple, that's why I started. But you have to solve 4 to 5 problems in each topic, then only you will solve in GATE exam. Otherwise you may be misconception will be there, so you may be misguided at the time of exam. So just don't remember this concept, you have to apply those concepts, but I mean from 4 to 5 problems, then only you will get answers in the GATE, right? So this is the final what you call concepts I am giving. So next we will see after GATE exam only, right? So, and final words I will say is, don't be panic or frustrated whenever you are not getting in this 1 week. This is a Monday and we will have Saturday and Sunday. This Saturday and Sunday, 5th, 4th and 5th. So be cool. So you will get what is, suppose you studied so much time, so we will get what is the destiny is made for us. So don't be panic, just go for revisions and 1 mock test, 2 mock test day by day, right? So all the best for the everyone again.